In this module, let us look at some of the curve fitting techniques. We've seen the various types of regression techniques and types of regressions that are available, including linear, logistic. It's also, we've seen polynomial. So let us see what curve fitting techniques are available. But before that, let us understand what curve fitting is. Now this is simple, and some of it you might have already guessed by the time we did the various types of regression analysis that is available. So let's say you have any particular curve of any form, and I'm just drawing some curves here, right? So if these are your data points, then you need to find the equation, and the equation could be y equals to a function of x. And you need to find this function or fit the data points for this function in a manner that the data points actually match this curve. So your y equals to f of x should equal this curve. And if that is equal, then that is curve fitting. So curve fitting is the process in which you discover the function that actually fits these data points, right? Almost all of them to the least level of error. So getting your line to pass through all data points might be an extremely ideal case, so that may not happen, but getting as close to as it can is the concept of curve fitting. Now, if I were to take one more example, and let's say we had to do linear curve fitting, right? So in case of a linear curve, let's say these are our data points. I'm going to take them a little spread out, but a linear line would make sense. And let's say the line is something like this. This is your curve fitting line, right? Now, this is how you want to fit these data points. Now, what would be the equation that you would take? So the equation for y equals to f of x in this case would actually be y equals to mx plus c, right? So this is the equation, y equals to mx plus c. So this particular thing is the equation for a straight line. And what is the process of curve fitting? So the process of curve fitting is essentially the process of finding the value of m and the value of c. So these are the only two items that you can find out. So as long as you find the value of c and the value of m that corresponds to this particular line, you have done curve fitting. So x is going to vary. It's a variable. Y is a variable. So you're finding the relation between y and x. That is what you're doing in the curve fitting process. But this is a linear curve fitting that you're doing. So the relation between y and x is governed by a constant influence, and it's governed by a slope of the line, or m as we call it. So as long as the process of curve fitting would only be discovering the m and the c to get this particular line that we have here. And that is simply curve fitting. The most common type of curve fitting is a polynomial curve fitting. And a polynomial curve fitting would typically fit most of the curve fitting requirements that we have. And in case of a polynomial curve fitting, we are simply going to take a polynomial equation, and we're going to try and fit the data points into the polynomial equation. So let us look at what are the various types of polynomials that we can take, and what are the curve patterns for each of those polynomials, so that you can actually take those polynomials and fit them to your curve. So looking at your data also, you may be able to estimate what polynomial would actually fit your requirements. So the simplest form of a polynomial is a first degree polynomial, and this is y equals to ax plus b, or y equals to mx plus c. So this polynomial will fit exactly two data points, right? So it guarantees to fit exactly two data points, and this will essentially be a straight line. So if you're using the first degree polynomial, it would effectively be linear regression. All other degrees of polynomial would be non-linear regression. The second degree polynomial would look like y equals to ax square plus bx plus c. Now again, in this case, the process of curve fitting would mean that you have to find the value of c, you have to find the value of b, and you have to find the value of a, right? x and y remain as the independent variables, and you have to find the value of a, b, and c to fit your data points. The second degree polynomial will fit exactly 3 data points. Moving on, a third degree polynomial would look like ax cubed plus bx squared plus cx plus d. Similar process where you have to find now the value of a, b, c, and d that fits your polynomial curve, right? So how do these look like on the graph? And let's see this. So if you see here the red line that you're seeing here, right? So this red line matches which is a straight line, matches a first degree polynomial. The green line that you see, right, which I'm hovering above, so this particular green line matches a second degree polynomial. So it will take it will take 3 data points, and it will fit the 3 data points perfectly. Now, so where is the data? So you see these black dots, right? The black dots are our data, okay? So these black dots are the ones where our actual data points are, and then we're taking different polynomial equations to fit these data points, right? So if we take the linear polynomial or the first degree polynomial, we get a straight line. So this is actually going through the center, right? So this may be equidistant, right? So this may be equal distance, equal distance, equal distance, right? So we're going through the center, and it's going to be a straight line. This is a second degree polynomial which is going to fit 3 data points. It kind of matches the curve a little more. Then if you look at the orange line is a third degree polynomial. And in case of the third degree polynomial, you can see that it is matching the curve a little more, right? So your actual data points are getting matched a little more. But if we continue this, right, then we go to the fourth degree polynomial, and the fourth degree polynomial is the blue line. And we can see for this type of waveform and this type of data points, the fourth degree polynomial is actually working well, and it's fitting for us, right? So this is what polynomials work. So you could look at the variation of the curve. So you start with the straight line, then you start with a polynomial, second degree polynomial that fits 3 data points, third degree polynomial that fits 4 data points, and then you start with a fourth degree polynomial that fits 5 data points, right? And that is how the curves work. And the process of so given this data, which is the black dots, you have to start finding out which curve fits, and then you need to find out the independent components, the fixed components like the a, b, and c, that the constants and the multiples in the curve. Those are the values that you have to discover, and the process of discovering those values is curve fitting. And when you found the right values that match your curve, in this case it is the fourth degree polynomial, and that is then you have successfully done curve fitting.